Hey, hello students. In this video, I'm working on lesson number 5, sequences are functions. This is 5, unit algebra 2 and unit 1. Straight away, let me go to the question. Problem number 1 says match each sequence with the one of the definitions. Note that only part of the definition showing relation between the current term and the previous term is given. uh, so as not to give away the solutions. Okay, so this is, let me pull this up. What I would do is I'll begin with the first one on the right side. Look at the sequence. So the sequence is given an, and it says 7 times, it's 7 times an minus 1. So what does this mean is any term, this means any term is 7 times the previous. Now, they didn't give us nothing here. Usually, you're supposed to give A1, A something. So they don't show us. We need to figure out which among this is multiplied by 7. Okay. So that 7 is this 7 is the growth rate R. So if you see here, this sequence clearly you multiply each time you multiply 7. See, 2 times 7 is 14, 7 times 14 is 19, and so on. And so this connects here. So only thing is the first one is not given. So this is A of 1 is actually supposed to be 2. The first term, look at the first term is 2. So that's the 2 here, right here. So this one they did not show. This is the recursive definition. Hope that helps. Now, the second one is, this means, what does this basically mean? Any term, so let me write this, is any term is half of, so any term is half of previous terms. I want you to get this. Any term is half of previous term. And you can see this seat which is showing up here. What is the rule here? Each time 160. So if we have 160, so half of, if you multiply by half of 160 is 80, right? Then half again, you multiply half, get 40. So clearly this is the answer for this one. And you have to explain why you say this. And what is missing right here is the very first one is 160, right? So you're supposed to write here B of 1 is 160, begins at 160. What about this one is why this is correct? What this means is each term each term is 6 more. What is that means is 6 more than the previous. This means the one before. So n minus 1 means one before. So the step number one before. So that means does this sequence satisfies the condition? And you can see it begins with 6. So it begins with 6, and then you add plus 6 more. So plus 6 is 12, and again plus 6 is 18, and there you go. And this is how you're supposed to get the answer. Let's move to the second question. Okay, the second question, I think I opened a wrong one. Here is the question. This is, let me open it again one more time. Okay. Yeah. Okay, in this example, in this problem number 2, the question is asked, write first 5 terms in each of the sequence and whether each sequence is the same. So again, you have, this time they give you, each of these examples is they give us a recursive definition or recursive formula. So the first one, let's begin with the first one is, okay, Look up for the very first term. So A of 1. So here, this one, A1 is 7. So I can make a table out of this. See. So the first one, let me make a table. And he says, write first 5 terms, right? So 1, 2, 3, 4, and 5. And the sequence name is A of n. The name is an, and this is n, step number. Now, because the very first number is 7, so I'm going to place 7 right here, correct? And what does this basically means is this minus 3 means any term. This means any term here. It means the next one, if I want to know, it is 3 less than, so it is 3 less than the one before. So if it is 3 less, that means I have to subtract 3. So when you subtract 7 minus 3, you get 4. And again you subtract 3 and you get 1. Again you subtract minus 3, you get minus 2. Again you subtract 3, you get minus 5. And that's all you're supposed to write. And this is the rate of change. It is also called common difference. And it is also written as lowercase d. And if you want, you can further write the nth term. So the n term is always a of n. Start with the first one, that is 7, and then you ask what is the rate of change. So I'm going to write minus 3 n times, and how many. So anywhere. Let's see if you want to do the second one. So you're you're taking away minus 3 once. If it is 3, you're doing it twice. If it is 4, then you have 1, 2, 3. So it's always 1 less. So it is n minus 1. And this is for n greater than equal to 1. So this is also the n term. Okay. So let me go check the, the second problem. So even though I'm taking little time here, I really want you to understand this. So the numbers. So make a table in your packet. Okay. So make a table. So this one for this. Okay. Make a table, and it is b, right? The sequence is b. So if I start with n, it is b of n, and 1, 2, 3, 4, and 5, right? And the number starts with 2, so I have to place the 2 right below 1. That's the 2. Now, what does this basically mean? This means you multiply by 2. So the previous term is supposed to multiply by 2. So if I want to write here, you need to multiply 2 to 2. So this big 2 is right here. And then also you have to decrease it by 1. See? So minus 1. So 2 times 2 is 4 minus 1, you get 3. Again, you multiply 2 because there is a 2 here. So 2 times 3 and then decrease by 1, which is 6 minus 1 is 5. Again, you do the same thing, 2 times 5. So double it and take away, and you get 9. See, double the 9 and take away 1. 2 times 9 is 18 minus 1 is 7. And that's, now look here. Here, if this thing was missing here, then we could have said that it is a geometric sequence because you're multiplying by 2. Or you could also call this sequence as if this 2 was missing here, and if it was only this side, this way, taking away minus 1 each time, then it would be arithmetic sequence. But right now, it has both. You're multiplying by 2, and you're also taking away. So it cannot be, so none. So this is not arithmetic sequence, and it's not geometric sequence also. Okay. So hope that helps. And let's see the next one. Make a table again. So I'm using the same thing. So this one is C, so I'm going to write C of n, right? Start with 3, so I write 3 right here. And then you multiply by 10 to the previous. So what does this mean is each time you multiply by 10. So 3 times 10 is 30. See? 30 times 10 is 300 and 3000 and so on, right? And 30,000. So that means there is a growth factor here, which is growth factor R, or it is also called common ratio. So this is a geometric sequence. The last one is a very interesting one. So it said there's a step number is multiplied. So it begins with, so if this is d of n, and this is n, and it begins with the 1. So that 1, I'll use the red color. And what you do is you're multiplying by the nth term. So you're multiplying by, if I want to know the second term, because this is the second term, right? N is 2 here. So 2 has to be multiplied. 2 times 2 is 4. So when you multiply the next one, so here the n term, that the step number is 3. So you're multiplying 3 times the previous, see, the 4. So fourth, you get 12. Now here n is 4. So you're multiplying 4 to the previous number, which is 12, which is 40. And likewise, you can get. So let's go to check the next problem. Okay, here you're given first 5. So what do you think is the rule here? So you're given the first one is 2. So you get 2, 4, 6, 8. And you can clearly see I can make a table out of this. And the rule here is, and you can see that because it is a, and I can just write n and a n, and you can see it goes by plus 2. So what is the rule is there is a rate of change. So each time we are adding plus 2, that is d. And we can write also this in the recursive definition. And the recursive definition is this is arithmetic sequence. There is a rate of change. And that means the very first one, that is a of 1, the first one is 2. And then any term is always adding plus to 2 more than the previous one. So it is the previous one, which is n minus 1. So I'm going to write a of n is the previous one, means for the number in the one before. So that's n, what is one before here. So if I'm writing the second one here, 1, 2, 3, 4, the one before, and then you're adding plus 2. And this is when, see, this whole thing is together called recursive definition, and say this is n greater than equal to 2, because this part is for n is 2, 3, 4, and so on. So that's the first one. In the second question, you can see what is the rule that you see. They are all odd numbers. They begin from 5, or you're adding to, again, the same kind of example. This time you're saying this is b, so I can say this is b, and the numbers are, okay, and the numbers are 5, 7, 9, and you can see again you're adding plus 2. So when you write the recursive definition, you say, okay, b of 1 is 5, and any term is always 2 more than the previous one, n minus 1 plus 2, but this is n greater than equal to 2. If you see this problem, the second one, it starts with this. So I can also, this is c, right? So you say, okay, c of 1 is 50. And you can clearly see it goes down by minus 25, means you take away subtract. So each time you're subtracting 25. So any term is always c of n minus 1, and you have minus 25, and you're for n greater than equal to 2. So that's it. So this is how you're supposed to write the recursive. The goal here is, can you write the recursive definition? Or each term is 25 less than the previous. So this you can describe in your own English words, or make a table. See how I do, right, showing the table also. And rest to the last one is D, the sequence D. What do you notice here? Each time you multiply by 3, right? So how do I write this in the? Of course, you can make the table is already right there. This is the table, okay? So the table is right here, and then each time any term is, you see this 3 times, so you're multiplying 3 to the previous term and you get the next one. So so multiply 3, so the common growth factor is r, which is 3. But how do you write in the recursive definition is d of 1, the very first term is 1/3, and then any term dn is, any term is always 3 times the previous one. So dn minus 1. and this is for n greater than or equal to, and you're done. So hope that helps. In this example, you are given a function notation, that's the first one, and you have another function. So you're given two functions, f of x and g of x. All you do is plug it in here. So you plug it in. So if I can make a table here and say, okay, they give you 3, 2, 1, 0, and -1. So if this is n x and this is f of x. So each time you say, okay, 3, 2, 1, 0, and -1, right? And each time you plug in the number. So what does this mean? So you double this, so 2 times x, so it is 2 times the x3 because this is 3 and -7. So 2 times 3 is 6 and -7 is -1. And this is how you do all the time. Okay. So if this is 2, you just plug in 2 right here. So 2 times 2 -7. So 4 minus 7 is -3. Again, you put 1 now. 2 times 1 -7, and you'll see -1. Likewise, I want you to complete the next one. This one, you're going to multiply itself. So this is x and g of x. And they're asking you the same numbers like 3, 2. I'm going to skip 0 and then -1. So how do we do this is we just have to plug in the value of x. So if this is x is 3, put the 3 right here. So it is 5 raised to 3, and you multiply 5 raised to 3 itself, 5, 5, 5. 5 times 5 is 25 times 5 is 125. Oh, my hand is paining. Then the next one is 5 squared, so it is 5 times 5, which is 25. And then next one is 5 raised to 0, and you remember any number raised to 0 is always 1. And the next one is uh, 5 raised to -1. And whenever you have a negative, it means it is 1 over 5. Done. Hope that helps. So in this example, all you do is figure out. So there are two, the black one, let's do the black color. So the black color is the B sequence. So this is the B sequence, and you can start with 1. So that's how it starts. And you can see this number is at 1. So this means it is 1 is 1. So this is 1. Then this is 2 is 2. This is 2. So then 3 is 4, and 4 is 8, and that's all you do. See, 5 is 16, and 6 you can't see, there's a 30. So basically what you're multiplying is each time you multiply by 2. See, multiply by 2. So there is a growth factor which is 2, not just growth factor, it is also called common ratio. And that's all you're supposed to do. The next one is the blue color. It starts with -1. So let me take this off. I'm just making last 1 minute. Yeah, just make it quickly. Okay, this is -1. Start with -1. So there's -1. Then 1 is 1. So there's a 1. And 2 is 2. So this is 2. And 3 is, oh, sorry, I made a mistake here. Somebody disturbed me. Okay, so this start with -1, and then this is 2. So this is not, this is 2. And then you can clearly see it goes, there's a rise over run here. Let me do quickly. So you run, you go rise 3, right? So that goes on. And again, run, 1 run, 3 up. 1 run, 3 up. 1 run, 3 up. 1 run, 3 up. So each time you're adding 3. So 2 plus 3 is 5 plus 3 is 8 plus 3 is 11. 11 plus 3 is 14, and so on. So each time there is a common difference, which is 3. Okay, so you can also write a sequence in the arithmetic sequence is an is always the previous one, and you're adding 3 and n greater than or equal to 2. For this one, for this sequence, you can also write b of any sequence is always 2 times. Okay, I hope this video helps just to understand how to write recursive definition. Thank you. My classes come next. I have to stop and hope this helps.